Hello, the topic I am going to discuss is Introduction to Semiconductor. It is known by all that metals are good conductor of electricity and insulator are bad conductors. The conductivity of semiconductor lies between that of metal and insulator. Therefore, semiconductor are material having conductivity in between metal and insulator. Since the conductivity is high for metal, the resistivity is low. Therefore, insulators are highly resistive. Resistivity is medium for semiconductor. We can explain it by the presence of loosely bound electron in atom which can be detached from it. Such electrons, when are torn from atom, they are referred as free electron. Metals have a large number of such free electrons. We can explain it by considering first the atomic model by Rutherford proposed in 1911. Now, according to Rutherford model, an atom is made of nucleus having positive charge and surrounding it electrons are moving. This is called orbital structure, but this structure has a drawback that since the electrons are moving surrounding the nucleus, when an electron radiates, it loses energy, therefore the radius will decrease, and in this way when an electron will start radiating energy, ultimately it will collide with the nucleus and the structure is not having any stability. To explain this phenomena, Bohr further made some changes or added something to Rutherford model to make this model work. This is called Bohr's postulate. According to Bohr's postulate, not all energy levels are possible. Only few finite energy levels are allowed in which electrons can move. So, while electrons are in those energy levels, they cannot radiate energy. In a transition from one stationary state corresponding to a definite energy level to another state corresponding to another energy level, they radiate energy, and the frequency of this radiation is equals to the difference of energy of these two energy level divided by Planck's constant. A stationary state is determined by the condition that the angular momentum of the electron in this state is quantized and must be an integral multiple of h by 2 pi. So, Bohr's model combined Bohr's model explain that in an atom there are finite fixed energy level. Now, X-ray and other studies show that metals and semiconductors are crystalline in nature. Crystal is regular repetitive array of atom in space. The energy level discussed so far is therefore not applicable for crystal. The outer energy level are affected by formation of crystal due to the presence of neighboring atom, but the inner levels are not affected. If there are n atoms in a crystal, outer energy level will be splitted in closely spaced n sublevel and they can be treated as continuous band. So, instead of energy level in isolated atom, energy band is applicable for crystal. The outermost filled energy level is called valence band, or energy band is called valence band, and the innermost or lowermost empty band is called conduction band. When an electron is in valence band, it is not available for conduction. It has to move to conduction band and then it will be treated as free electron. Here, metal, semiconductor and insulators are compared in light of their energy band diagram. In case of metal, the valence band and the conduction band are overlapping. Therefore, electron can move from valence band to conduction band very easily. That's why metals have a large number of free electrons and they are good conductors. In case of semiconductor, the gap between valence band and conduction band is less and at room temperature, electrons can move from valence band to conduction band. In case of insulator, the gap between valence band and conduction band is very large. That's why insulators are bad conductor, because valence band electrons, they require much larger amount of energy to move to conduction band in case of insulators. Now we will discuss about semiconductor. What is intrinsic semiconductor? Intrinsic semiconductor is basically pure semiconductor. Silicon and germanium are two most important as well as common semiconductor material. They are group 4 element and they have 4 valence electron which take part in covalent bond formation with 4 neighboring atoms. At 0 Kelvin, the crystal of semiconductor behaves as an insulator since there is no free electron available. At room temperature, some of the covalent bonds are broken because of the thermal energy supplied and conduction of electricity is possible. The energy required to break a covalent bond for silicon is 0.72 electron volt and germanium is 1.1 electron volt. The absence of electron in covalent bond is called hole and it is also considered as positive carrier of electricity. So electron and hole both are carrier in semiconductor. When group 3 or group 5 impurity is added to a semiconductor to increase conductivity, the process is called doping and such semiconductor are called extrinsic semiconductor. When a semiconductor is doped with group 3 material like boron, indium, etc., semiconductor is called p-type. In p-type material, holes are majority carrier. Group 3 are called acceptor. When doped with group 5 material like phosphorus, semiconductor is called n-type.